Hello and welcome to another episode of Earth911's Sustainability in Your Ear. I'm Mitch Ratcliffe, your host, and we're back with another innovator interview. You know, algae blooms in freshwater, bodies of freshwater, are an increasing problem around the world. Cyanobacteria, which can poison not only the lake water itself, but the animal life in the lakes, is striking more frequently around the world as temperatures rise. And we invited Eyal Harel, who's the CEO of BlueGreen Technologies. It's a company that treats algae blooms, to come on and talk about what's going on with our fresh water supplies around the world. Eyal, how are you today?
Excellent. Thank you. Thanks for having me on your show.
Well, welcome. And it's a pleasure to have you here. So first off, your company deals with cyanobacterial blooms in lakes and other waterways. Why are these events becoming more increasingly frequent?
So algal-blooms, which is the nickname for a problem called cyanobacteria, is something that didn't start in the last couple of years, although it has become a menacing problem, as you've mentioned, in a more frequent and severe way all over the world, only in recent years. Cyanobacteria is an ancient species that has existed long before humans have. It's prevalent all over the world, and normally it coexists with other species and without any issues or problems. Over the last decades, not to say centuries, with humans polluting the earth, global warming, and generally speaking, convenient locations where the geology, for example, is fruitful with abundant levels of nutrients. Over the years, cyanobacteria have managed to overtake the ecological niche a little by little, simply by multiplying, changing the biological, chemical, physiological properties of the water to their advantage. So the problem that we're facing today with the harmful algal blooms in lakes and in seas is the product of many years of what we call the cyanobacterial inoculum growing in the water from year to year, becoming bigger, more dominant, more aggressive, all the way until it blows in the form that it does today.
So I happen to live near a lake that has been treated twice in the last decade for this kind of algal bloom. And it seems one of the contributors is human pollution. You mentioned that before. So is it fertilizer runoff? What are the kinds of pollution that contributes to a bloom?
So there are many contributors to the formation of a bloom. And mind you, some 50% of all lakes in the world, some 60 million lakes, are contaminated to a certain extent with harmful algal blooms. The main culprits, so to speak, are, of course, nutrients in the water, mainly phosphorus. That can come as a runoff of fertilizers from agriculture, as well as global warming, rising temperatures, and like any other bacteria, they prefer warmer areas. However, we see blooms on the rise, also in areas where there is hardly any human presence or influence. We see harmful algal blooms in lakes, in cold areas, including in the Arctics. So there is not exactly a one-size-fits-all. There is not a single factor that would generate an algal bloom. It's a combination. It's a very complicated system, a lake or an ocean, and so there are many factors that are contributing to the formation of algal blooms.
We'll get back to that for a moment, but I'd just like to understand too what happens to the other life in the water when a bloom takes over a lake. I understand, it chokes them out because there's less oxygen, but what are the other consequences of a bloom for the other life in a body of water?
So from a biological point of view, we see a single species dominating the entire ecological system. It's under bloom conditions, you can have cyanobacteria dominating some 99.9% of the ecological niche. So everything else is pushed out and dies. I would just like to correct one statement that you've made about the lack of oxygen. So cyanobacteria is a photosynthetic microorganism. In fact, they generate oxygen. Cyanobacteria is the reason why we breathe oxygen from an evolutionary point of view. So like any other green matter in the world, just like trees and algae, cyanobacteria during daytime while doing photosynthesis generate oxygen. And if we measure, and we do, oxygen levels in the water during daytime, they exceed 100%. So 100% would be normal. However, during nighttime, it's a switch mechanism. They start consuming oxygen. And during nighttime is when we see drop in oxygen levels, and that is when we usually see the fish kill that suffocate due to lack of oxygen. So that is just to put things in the right perspective.
Thank you. I did. That's a great clarification. I had always I guess I'd focused on what happens at night when I was reading about this. Now, one of the other things I've been told, and correct me if I'm wrong, is it is not healthy or safe to eat, say, fish that you were to catch in a bloom-infected lake. Is that correct?
That is correct, and I'd like to highlight this issue because I think it is understated, and most people don't quite understand what's the meaning of a toxic algal blooms. So I'll start from the immediate and present danger.
Great.
Cyanobacteria, and by saying cyanobacteria, I'm actually referring to a range of different specific species, but generally speaking, cyanobacteria release a lot of metabolites. Many of them are toxic into the water. From a scientific point of view, we are familiar with 8 different toxins, but probably there are many others. Of the ones we know, these toxins are extremely potent and they can hurt the brain, they can hurt the liver, they can hurt the skin and the digestive system. Very, very problematic and responsible to deaths and injuries and sicknesses in humans, animals, fish, and whatnot. The toxins cannot be boiled, so boiling won't help to remove the toxins. You'd have to undergo a very aggressive treatment in order to remove them from normally from drinking water, but otherwise in nature, they persist for quite some time. So this is the problem we're dealing with. So whether you irrigate with infested water or you fish in infested water and then you consume those kind of animals or vegetable or fruits, then you are being exposed to cyanotoxins. But more so, there's a growing number of studies in the world in recent years that is showing that cyanotoxins become airborne with aerosol and travel as far as 5-10 miles away from infected lakes. So actually, nearby communities inhale them day in, day out, and you can see increased prevalence of Alzheimer's disease, Parkinson's disease, ALS, non-alcoholic liver syndromes, and so on. And this is the real danger. So this is just to cover the health aspect.
Right.
Now, what is, I think, very important for everybody to understand is when do you actually have a toxic bloom at hand? And the international definition said by WHO and the US EPA is 20,000 cells per milliliter. Now, when you're looking at a glass of water with 20,000 cyanobacterial cells per milliliter, you see nothing. This is clear water. So,
and yet it's still already heavily infected.
And that is already a toxic bloom in progress. Exactly. So when you're seeing a bloom in the lake with the naked eye, we are way beyond a problem. We're deep into a toxic algal bloom that needs to be mitigated, and time is of the essence because under prime conditions, cyanobacteria can multiply every 3-4 hours, meaning 10 cells turn within 3-4 days into 170 million cells, and the problem becomes bigger exponentially. So So it's very, very important for people to understand that when they see the problem, it's already deep into the problem. And they need to be aware of the fact that lakes that are prone to algal blooms, the problem has started long before they could see it, and which brings to the front the importance of monitoring and the availability of information to the public in order to maintain public health.
So now you mentioned earlier that as the planet warms, and particularly in the northern regions, and I suppose also in the far south near the Antarctic region, we're seeing more of these algal blooms in lakes and streams. How do you project the expansion of this kind of algal bloom incidence globally as the planet warms? Are we looking at a linear acceleration, or would this grow exponentially?
It's difficult to talk about whether it's growing linearly or exponentially, but it's definitely growing. So there's a number of studies done showing that all over the world, east to west, north to south, the overall number, frequency, and severity of algal blooms is on the rise for all the reasons we mentioned before. The inoculum in the water continues to increase, and it just it won't stop unless being treated.
Now, does this also threaten our fresh water supplies, drinking water supplies, and particularly groundwater, where lakes filter water into the underlying strata? Is the cyanobacteria toxin carried along with it?
That's a very interesting question. So the fast answer is yes. There is an example in China where they used to attempt to mechanically remove cyanobacteria with kind of vacuum cleaners that would
filter it out.
That would suck the scum out of the water, and through centrifuges they would bring the water back into the lake, and then they got stuck with all this organic matter that was sitting outside the lake, and they didn't know what to do with it. So number one, they didn't fix the lake because obviously it's bacteria. You can't really deal with it mechanically. But then they thought, okay, we're going to recycle all this organic material, and they used it as they thought they would use it as fertilizers in the fields. They ended up intoxicating the entire crops where it was used. But more importantly, and the interesting piece of research information that came out of it was that the toxins went down to underground, all the way to underground water, contaminated, intoxicated the underground water. And through this process, at least they learned the half-life of the toxin, which is, if I remember correctly, 17 days.
Mm-hmm. Now, have you seen a change in the way people are monitoring local water during the pandemic? Are we taking our eye off of this environmental issue as we deal with this massive health crisis?
So there's a good news and there's a bad news. In the what we call the Western world, overall there has been no impact in terms of making sure that water is either clean or that monitoring is in place in order to warn people of harmful algal blooms. It's not perfect. In many cases, local authorities rely on people reporting on sightings of algal blooms. And as I've mentioned before, that means that they've actually missed on days, weeks, months of an algal bloom in progress. Right. But still, it's better than nothing. I just came back from South Africa, where COVID sucked in all the oxygen and money away from other resources, including water. So where they already had relatively low standards in terms of water quality, they actually reduced those standards. So unfortunately, we actually sample tap water and find toxins in tap water, which they don't monitor for in most of the water treatment facilities, which is really a humanitarian tragedy from our perspective.
Now, and that again reflects the inequities of the way that we manage our natural resources, and they're exacerbated by events like COVID. Now, let's talk about how we can treat this. You make a product called LakeGuard, and the key ingredients in that are hydrogen peroxide and copper sulfate. Is it safe to use those materials in natural waterways?
Yes. So actually, we're talking about two separate products. There's the LakeGuard Blue that is based on copper sulfate, and the LakeGuard Oxy is based on sodium percarbonate that releases hydrogen peroxide. We have other products in the pipeline, but the reason we started with hydrogen peroxide and copper sulfate was the abundant use of these chemicals for as many years as they have. Copper sulfate has been used as an algaecide for approximately 70 years all over the world. Hydrogen peroxide was introduced approximately 25, 30 years ago. Mm-hmm. So these products are used, like I said, all over the world, including in drinking water facilities for many, many years. In fact, they're considered as water disinfectants. So there is everything there is to know about them, including short-term toxicity, long-term toxicity. And local authorities are quite comfortable and at ease with the use of these products. When it comes to treating surface water, lakes, right, they have serious shortcomings. The problem with these products is their weight. When you put them in the water, they immediately sink to the bottom and interact primarily with the sediment. So if you want to deal with a harmful algal bloom, our cyanobacteria, which is a photosynthetic microorganism, you have a built-in problem, because this is a four-dimensional problem.
Right, so it's floating, and the material drops past what it's trying to treat, if I understand you correctly. Is that what you're saying?
Exactly. Not only is it floating, it's moving all the time, right, based on currents and winds. So, and it multiplies all the time. So exactly, the product, when the generic product, when introduced into the water, sinks to the bottom, goes through, and only a small percentage of it is where it needs to be, and the rest interacts with the sediment and generates secondary pollution, which is a different problem. So if you want to take a lake and treat it with these generic products, it means you have to do a full lake application, and you have to shock treat the entire water column, which from an environmental perspective is let's say, not ideal. Overall, it's extremely expensive, ineffective, and limited to very, very small water bodies. What we did in BlueGreen Water Technologies was to take exactly the same chemicals, mm-hmm, and coat them with an inert biodegradable polymer, nanocoat them, mm-hmm, to change their physical properties. So with a very, very small contribution, 5% with the copper and 2% with the sodium percarbonate, we are now able to float and time release these compounds. So instead of sinking to the bottom, now they float alongside cyanobacterial aggregations and interact with them as they move. And by doing so, we were able to completely change the paradigm of treatment. We're not treating the entire surface of the lake. We're not shock treating the water column. In fact, we are surgically treating the lake in very specific locations from where the product is moving autonomously based on the same forces of nature that dictate the movement of the target. And by doing so, we achieve two things. The first thing, we're able to reduce the amount of chemical in the water by as much as 90-95%, which is already very important. But more importantly, what we are not trying to achieve is we're not trying to bleach the water and take out everything that's in it, every organic matter. What we're trying to achieve is a selective response only within the cyanobacteria. And we're doing it by creating a minor oxidative stress, a prolonged oxidative stress in the water along cyanobacterial aggregates. Cyanobacteria is the only species in the water that is extremely, extremely sensitive to oxidative stress. All the other species, much less so. Just to give you a reference, blue-green algae, that is the direct competitor of cyanobacteria in the water, is 50 times less sensitive to oxidative stress than cyanobacteria. By creating these conditions, cyanobacteria starts releasing biological signals into the water that are causing naive populations that did not come in touch with the chemical to undergo programmed cell death, which is why what you would see very fast within 24, 48 hours, you'll see the collective suicide of the entire cyanobacterial population in the water. It's extremely pronounced and very, very fast to see in the setup of an entire lake. Now what happens is that once we've seen the demise of the toxic species in the water, the way is now open for the non-toxic species, the natural competitors, to take over the ecological niche, which they do, because there's no vacuum in nature. And now we have the non-toxic species serve as a natural buffer against cyanobacterial resurgence. So to put it simply, we are rehabilitating the aquatic environment, bringing it back to pre-cyanobacterial domination in the water.
Well, and what happens to the toxins that were produced by the cyanobacteria before it was treated? Does that filter out over time? How does that work?
So yeah, cyanotoxins have a limited lifespan. I've mentioned before they have a 17-day half-life. Under bloom conditions, the water is already toxic. So when we're going for a remediation project, meaning there is already a severe ongoing bloom, the water is already toxic, and it will continue to be toxic until we deal, first of all, with cyanobacteria that keep producing toxins. Once we have removed the problem of cyanobacteria, within a couple of days, the level of toxins will diminish naturally. But this is when we come and we have to deal with an ongoing bloom. Ideally, our approach is to prevent blooms from occurring altogether. And this is, for example, what we are doing in Lake Minneola in Florida. Mm-hmm. And the idea is really to identify, monitor carefully and identify the blooms at their very onset before they reach the 20,000 cell per milliliter threshold. And as I've mentioned before, treat them surgically with very, very small doses in order to make sure that no bloom occurs in the first place, in which case there are no toxins in the water in the first place. And this is something that we're monitoring after very carefully, making sure that toxin levels doesn't even reach the threshold of a problem under state laws.
Well, Eyal, I want to thank you for taking the time to explain cyanobacterial algal blooms with us. It's been fascinating and good to learn. Thank you very much for joining us.
Thank you very much. It was my pleasure.
Folks, that was Eyal Harel. He is the CEO of BlueGreen Water Technologies, an Israeli-based company. He was speaking to us from Berlin, by the way. And we will be back with another episode of Earth 911 Sustainability in Your Ear soon. In the meantime, please take time to share this podcast with your friends. Sustainability is a team sport. Let's spread the word. And take care of yourselves, take care of one another, and let's take care of the planet.